So very good afternoon, Foundrymen. It gives me immense pleasure interacting with you all for the 14th technical webinar for the year 2022-23, which is being conducted by the Institute of Indian Foundrymen, Chennai chapter, online through Google, through Microsoft Teams platform. So to get things started, we now request our Chennai chapter Vice Chairman, Mr. V.K. Raman, to welcome the guest.
Good afternoon. Yes, am I audible?
Yes, sir, you're audible, sir.
Yeah, welcome, Mr.Debraj Sinha.
Yes, sir. Hello, sir. Very good afternoon. Good afternoon to all.
Good afternoon. It's our immense pleasure to welcome you all for this fantastic presentation to be given by Mr. Debraj Sinha. Any foundry operation couldn't be possible without the support of hydraulics. That is a prime mover for foundry operations, whether it is molding, core shop, fettling, or whatever be the activities with regard to foundries. So in this connection, Rexroth plays major role in supporting foundries through their hydraulic equipments and ensuring the precision. That is a precise movement of mold boxes, precise clamping of boxes, precise squeeze pressure. Everywhere the precision is required. The precision is must to ensure the quality. So unless the precision is maintained, quality cannot be ensured. So in that way, hydraulic systems are playing major role in supporting foundry activities.
2 minutes.
So to enhance our knowledge on hydraulic system and the functions of hydraulic system, Mr. Debraj Sinha, manager, Rexroth, which is a Bosch company, accepted our request, and he is going to give us detailed presentation on hydraulic systems and valves. So I request all fellow foundrymen to attend this program fully, so that our doubts and clarifications on hydraulic system can be fulfilled. So any questions on this program can be raised at the end of the session, so that Mr. Debraj will be in a position to give full explanation for all the questions. So request all the fellow foundrymen to fully attend this program till the end. So now I request Mr. Vignesh Ramanan to introduce the speaker to the forum. Thank you. Over to
Thank you. Thank you, Raman, sir. So now introduce the speaker for the day. I request Mr. Rajmohan Madhyaragan, Council Member, IIF Chennai chapter, to introduce our speaker to the audience, please.
Thank you, Vignesh. It's my privilege actually to introduce the speaker of the day, Mr. Debraj Sinha, Manager, Engineering and Application. Since 2017, he is working in Bosch Rexroth. Mr. Debraj holds a total of 12 years of experience in metallurgy field. He has worked with several OEMs, and to name some key OEMs are SMS India, Daniel India, and M&N Dastur. Sir, we now request you to address the audience, please. Thank you.
Thank you very much
Thanks,
for
Raj.
the introduction.
Sinha, the floor is yours.
Thanks. Thank you very much for the introduction. Okay, I will minimize this. Okay. So first of all, hello and very good afternoon to all. It's my immense pleasure to be able to participate in this program. Though it's a puja days, it's a Vishwakarma puja days, but I still believe it's very important that you have given us the opportunity. So henceforth, I will, or as an organization, I would like to express my gratitude to the honorable dignitaries of IIFL Chennai chapter for giving us the opportunity to showcase our product as well as technology in this forum. Being a multi-technology provider, Rexroth has a vast product range. I think it will take a lot of session to complete the whole range, but today we will try to restrict our discussion on the axial piston pump operation and the proportional valve. Not only that, we will touch upon other aspect also, like foundry industry, the global and the domestic market, as well as the forecast of the domestic market. We'll also touch upon some new and interesting focused product of Rexroth. And later on stage, we will take your queries and I'll try to give you the answer if possible. So let's move ahead with the agenda of the meeting. So the today's agenda is, first of all, we'll start with Bosch Rexroth saga. It includes Bosch Rexroth DC as well as Bosch Rexroth India, their whole history, as well as the production units, the organization strength, and the total turnover. Then we'll go to the foundry market, global and domestic, as I mentioned earlier. Then the foundry market insight. Then the Bosch Rexroth Indian product. Right. Bosch Rexroth in Indian foundry market, and what are the products are being used in the market. Then we'll directly jump into the main aspect of the program, that is your pumps in the open circuit. Basically the VSO pump, A10 VSO and A4 VSO, their pumps basic principles as well as pump controllers. Then we will move to the proportional valves. We will cover the basic principle of the proportional valve, the principal operation of the proportional valve, the technology, the overall Rexroth product portfolio as far as the proportional valve is concerned, then the spool characteristics and characteristic curves, and last the hysteresis. Then the last one, we will touch upon the new and focused product of Rexroth, and last the question answer session. So that is the whole agenda of the meeting. So we will start our discussion with the history of Bosch Rexroth. Basically, it all started in the year in 1975, in the first industrial revolution time. At that time, Bosch Rexroth was a technology provider of a foundry and forging industry. But as the time passed by, we developed all the knowledges to fulfill the market demand, and we shifted our focus to the hydraulic industry in 1950s. In 1960s, we developed product portfolio such as electric control and drives, piston pumps and motors, as well as your linear motion technology. And by doing that, we develop ourselves to provide the complete solution to industrial and mobile hydraulics. In 2001, we have a merger of Management Rexroth with Bosch Group, Bosch Automobile Industry, and this collaboration gives an impetus to the organization and gives a new dynamics to the company. And till that, it continues. And our main focus and goal is to provide the sophisticated and sustainable solution to machine industry, manufacturing industry, as well as your daily work life. This I have talked about the overall DC point of view, Bosch Rexroth point of view. Now going to the Bosch Rexroth India structure, it's all started in 1974 in the name of Rexroth Maneklal. Then we have started our manufacturing activities in 1975. In 1985, we changed our name from Rexroth Maneklal to GL Rexroth. In 1988, we first started our HPU production, hydraulic power unit production at Bangalore. In 1994, as you have rightly seen over here, that we start trading, the market trading of these servo valves, pneumatic cylinders, and other linear motion technologies. In 1995, we have changed our name from GL Rexroth to Management Rexroth. In 1997, a big thing happens. We have changed our headquarters from our erstwhile Bombay to Ahmedabad. Now it's called Mumbai. In 2001, as I mentioned earlier, it was a merger of Management Rexroth with Bosch Automobiles. In 2003, we have reached the 1 billion INR company. In 2010, we have customizing new units at the Bangalore, and we have grown our sales from 1 billion INR to 6 billion INR. In 2013, we have shifted our manufacturing unit from a particular location of Ahmedabad to Sanand. It is basically outskirts of Ahmedabad. In 2016, we have rechanged our name to Bosch Rexroth India Private Limited. And after two years down the line, in 2018, we have achieved 11 billion INR sales volume. So that is the history of Bosch Rexroth India. Now, talking about Bosch Rexroth as a company, it's an ISO certified company. The total sales volume Bosch as a whole, it's in, if you go by the statistics of 2020, it's a 71.5 billion euro. We have the total associate nearby 4 lakhs. There are several industries where we are pushing our product and technologies for so many years. You name it, industrial technologies, be it automobile technologies, the energy and building industry, as well as consumer good industries. If you see our presence, it is there in 5 continents and across 80 countries. We have total 47 manufacturing locations unit, and alongside that we have customized location in 21 countries. This is the overall structure and the overall concept of Bosch Rexroth. Now coming back to the Bosch Rexroth India, in India we have total 5 sales region: North, East, then South, West, and Ahmedabad zone. And total we have 7 sales offices, including Delhi, Calcutta, Chennai, Mumbai, Pune, Ahmedabad, and Bangalore. We have at present we have almost 800 plus employees and 4 service center. We have a production location at Ahmedabad and Bangalore. At Ahmedabad, it's in Sanand, and it's Bangalore, it's called Hezala plant. So what are the features we have in the plants? If you go by the figures of the Ahmedabad unit, we generally produce the power units over here. Power unit includes your pump, your tank, your conventional valves, your cylinders. So if I go by the conventional valve, it means the DC valves kind of things, your isolation valves. So it's the production capacity is from NG6 to NG22. Now go back to the tank unit. We have the maximum potential of making the tank up to 60,000 liters. It's quite a huge tank.
Volume,
now coming to the
volume is good.
Exactly, it's about the volume. So 60,000 liters volume, it's a huge amount of volume. Then coming to the actuators, in India, as of now, we are producing cylinders at a bore of maximum 800 mm and a stroke of 6 meter. That is the maximum capacity we are having at Sanand plant at present. At Hezala plant in Bangalore, what we are doing, we are producing the external gear pump. The CC is 4 to 22.5 cc per revolution. So if you couple this pump with a electric motor, conventional electric motor, synchronous electric motor, so you will get a LPM near about maximum 30 LPM with 1450 RPM. So this is the structure and overall history of the Bosch Rexroth and Bosch Rexroth India. I will also show you some snaps of these photos. This is our Sanand plant, right? And this is our Hezala plant. As you see, this is the production unit are there. So they are basically preparing all these small sizes gear motor. Talking about the technology, what Rexroth provides to the market, we have a vast range of technology, but amongst them, it's industrial hydraulics and mobile hydraulics, which are on high demand for last 2 to 3 decades. In addition to that, we also have been doing some interesting and prestigious project in assembly, linear motion technology, drive and control technology, and resistant welding technology. Recently, we have added the new technology in the mobile robotics. So if you see the mobile robotics, just a moment. There are a few products that gives you a wonderful user experience. This product are a RoboKit sensor. Then we have RoboKit locator, RoboKit navigator, and RoboKit motor. I have also attached one attach one link to it. It's available in the YouTube. If you permit, I can play the video. It shows about the overall technology what we have been providing to the industry as far as the mobile robotics is concerned.
Please go ahead, sir.
Right. So just a moment. It's a 4-minute video. So I will request you to just go through this video. It will take some time. It will directly be downloading from the YouTube.
Yeah, please go ahead. No issues.
Yeah, it's an indigenous video of Bosch Rexroth.
Sir, I think there is no audio coming from the video, sir. I'm not getting any audio.
Okay. Audio is there, but
I think it's not coming through this.
right. So shall I continue with the video or I will stop it? Whatever. Audio is on, but maybe it's not audible at your end, right?
Yeah.
Without the audio, I'm playing this video, right? It's a very unfortunate from my side. Will that be okay, or I'll skip that?
If you feel
any explanation in the video?
Yes, sir. It's a very interesting video about the mobile robotics technology. That's why I have incorporated
Is there any background explanation or just video music will come?
Sorry, sir?
In the video, any background explanation is there?
It's not a typical background explanation, but an overview about this Ford product that I have shown just now, sir.
You just run the video. We will go through the video.
Okay.
Sinha sir, what sir is trying to ask is, will somebody be explaining in the back, or will it just be music?
It's only be music. Nobody is explaining it.
Then you can just play that.
Right. Yeah. Okay. Right. Thank you. Just a moment, I think. Right. So this video is about this mobile robotics. Maybe in India it's not that frequently we are using this robotics item, but in Germany and European country, that is in Rexroth as a whole is already pushing their product into the market and has already established their footprint. So that we have talked about the several kind of technologies that we are having at present right now. Now moving to the global and domestic market as far as this foundry industry is concerned. If I go by this latest data which is available, if I go by the latest statistics, this is the overall market scenario. The total production at a global volume in terms of MTPA is near about 110 MTPA. If I break it into major 5 countries wise, it is China, India, US, Russia, and Germany. And if I go by the contribution to the overall global volume, China is taking care of almost 50% of the market share. India is almost 10% of the market share. But these 5 countries that I have enlisted over here, this itself gives a 75% contribution to the total global volume. Right. So this is the overall figure as of now, as far as this global market is concerned. Now moving to the global to the domestic. This is the overall breakup of the domestic market as per sector wise. So as far as Bosch Rexroth is concerned, I think automobile market, your industrial market, agricultural market, and power market, these are the major 4 industry where we are already pushing our products for so many years. So this foundry industry is very important to us. We are pushing our product and we are providing the best solution to the customer, so that best quality quality of product can be given to the customer. Now talking about the market insight of the domestic, if I go by these few journals data, there is a huge amount of potential as far as Indian market is concerned. The pundits and the wizard of the market are expecting that Indian market might grow at a level of 10% CGR level. And while the domestic market, all the global market will see a 5% CGR growth. And if we project this growth from 2020 to 2027, so we have a chance of double it up our total production capacity. Yes, it's true for the pandemic reason, for COVID-19 reason, we are unable to fulfill certain heights that we should have achieved. But I think within the future days time, we will get up to that target. Now, what are the key factors for this growth, what the pundits are expecting? First of all, we have the sector is divided basically into ferrous and non-ferrous sector. So we need to have the growth in both the sector, as well as ferrous, as well as the non-ferrous sector, to have a holistic growth. So if we're talking about this non-ferrous sector, the aluminum casting, since your fuel efficient automobiles and electric vehicles are quite nowadays we can easily see in the roads. So as we increase the demand of the lighter casting material for this fuel efficient automobiles and EVs, there will be a surge in demand of aluminum casting production. Now coming to the main casting production of the metal industry, the expansion of the infrastructure of the government is expected to generate the demand of wide varieties of machines and equipment such as crane, fans, motors, pumps, and other things. So this in turn will create a fresh demand in the metal industry. As well as we also last 10 years or so, we increased our total power consumption capacity. So which means that your electric equipment should be upgraded in that way also, right? So once you upgraded your electrical component, so that your production capacity of the electric component has to go up. So that means you need much more domestic production of this electrical component, which in turn will surge in your casting manufacturing sector. And last of all, I think major of this, our industry, forging industry, based on this micro small manufacturing enterprise, that is MSME sector, and 55% 5% of this sector belongs to the rural industry. The incentive what this government is offering, such as Pradhan Mantri Mudra Yojana, Make in India startups and Skill India concept, are really helping this growth of this MEC sector. So this is the market insight of this domestic. Now coming back to this Bosch Rexroth presence in the foundry market, we have some major customers starting with the electro steels. For the electro steel, I think major product is ductile iron pipe and fittings, and that is used for the water and sewerage line. We have been giving lot of circuits basically as far as the HPU is concerned, tank, pumps unit, valve tables, logic valves to electro steels. We have already attached one typical circuit so that you can easily understand what we mean to say over here. I will click on this and I will show you one reference circuit that we have offered to the customer. This is an approved circuit. It shows a typical valve table. I hope it's visible at your end, right? It's a typical valve table. This is the boundary, okay? And we have a proportional valve over here and two cartridges over here. So the overall philosophy of this valve table is to move faster, and by doing that, to achieve that, we are incorporating a regeneration circuit over here. So this is a typical circuit that we have already provided to the customer, and the production is on with the circuit. So from the electro steel, we will go to another major customer of Bosch Rexroth India, that is Disha Group, and the product is obviously your Disha Flex machine. With the Disha Flex machine for last 5 to 6 years, we have already standardized this product. We have a huge experience of working with this Disha Group. I think you might be aware the capacity of this machine. It's a production capacity almost 100 to 150 molds per hour, but the casting weight, it should be about 20 kilo, and the material they use most of all is the ductile and the gray iron. For the Disha machine also, I have attached one more circuit which is quite relevant. This is a typical circuit we are providing to Disha. It's a basically Disha Flex 70 machine. This circuit and the whole machine has already been standardized, and we are also exporting this machine to the other country like Egypt, Spain. So this is a typical circuit which shows the valve table, the power unit. Power unit means your tank unit over here. I have to open the, I hope it's visible. It's a tank unit with accessories and pumps. Then you have your relief valve and ultimately your accumulator, and the logic it's set in the valve table. And in the above, you have the actuator. Maybe at a glance, it's not very easy and comprehensive to all of you, but my purpose is to show you is that we have been doing this project for last so many years, and ultimately Disha has given us the opportunity to standardize this product, and we have done it. Apart from Electro Steel and the Disha Group, we have other customer also, such as Ramkrishna Forging and Tata Metallics. For the Tata Metallics, we are not providing the technology directly. We are providing the technology via OEM. For the Ramkrishna Forging, we are providing the technology via the dealer. But all the 4 customers, we have done the projects. We have provided the technology and the product, and most of the projects are already commissioned. So from the major customer, now we will focus upon the Rexroth product. I have not incorporated all the product, but this product, whatever I have envisaged over here, this is basically belongs to the industrial hydraulics. I have basically intentionally put over here variable axial piston pump, only the A4V and A10V. Apart from that, there are various other products also, right? Like A11SO, other closed circuit operation, because these 2 pumps basically caters with the open circuit operation. Now coming to these pumps, the minimum CC is 18 cc to 1000 cc. So that means with a revolution of 1450 RPM, 50 RPM, you will get maximum almost 1500 LPM flow. And the maximum pressure for the A4 VSO is 350 bar, and A10 VSO is 280 bar. Now pumps to the directional valve, As I shown you earlier, in the Sanand plant, we already have the capacity of producing this directional valve at a range of 6 to 22. From 22 onwards up to 32, it's the imported products. We procured it from the Germany. And talking about the LPM capacity, max to max, I believe it's a 600 LPM that can take care. And talking about the pressure, it's a 350 for this directional valve. Moving to the isolator valve, it basically nothing but the pilot operated check valve that most frequently we use in the hydraulic circuit. These products we produce indigenously at the Sanand plant. Our main features is basically SL and SV. If you Google it, you will find it. It's a pilot operated check valve. Then we have the proportional valves, range is 6 to 32. At present, these proportional bars not being produced in the Sanand plant. We procured all this thing from Germany. But we have a near future, we are having a plan to produce in India. Then I will go to the detail of the proportional valve in the later on stage. Moving to the transmitter, we have two separate transmitter, HED10 and HM20. HED10 is this one. You will get a display over here, and that will transmit a 4 to 20 milliamp analog signal. You can interlock the signal in the PLC, and automatically you will see the figure of pressure in the PLC as well as in the local display. HM20 is an additional, has some advantage over HED10. The hysteresis of HED20 is much lesser than HED10, so you get a better accurate figure with the operation of HM20. Basically, in the metallurgy industry, we use in the rolling mill industry HM20 automatic gauge control, where we reduce the thickness of the strips. But one disadvantage is there, we do not have this local display in HM20. Then we have the temperature switch, we called it ABZMT. All the product of the ABZMT already having this local display unit. At the same time, it can give you an analog signal that you can interlock in the PLC, so that you can see all the parameters locally as well as at the PLC. Coming back to the accumulator, we have a model HAB that the capacity up to 50 liters. It's a bladder accumulator. This accumulator basically C certified. So at present in Sanand, not in Bangalore, both the cases we are not able to produce this accumulator. We import, like proportional valve, we import this accumulator from Germany. Apart from that, to operate this accumulator, we have another safety shutter block valve. So this block we use at the bottom of the accumulator, so that the accumulator can be easily maintained and operated. This valve is also not being manufactured at present in India. We import this valve from Germany. Then we have the modular valve. This incorporate lot of valves, means we called it pilot operated valve. Then we have the stackable flow control valves. These all valves from NG6 to 32, maximum 6 to 22 are being produced indigenously, but above size we are procuring from the Germany. Right. So this is the overall product portfolio of industrial hydraulics that we are already used or being used in the foundry industry. Now coming to the main topic of the pumps in the open circuit, the philosophy of A10 and A4B SO. To understand that, I think this figure is very important. We have to understand two things. Pumps is coupled to the motor. So as the motor moves, the pumps will automatically start to rotate. So we have a shaft over here. So this figure is a bifurcation, or maybe you said a cross-sectional view of the axial piston pump, where we can see this is the Swartz plate. And if you juxtapose this figure with this, so I would say this is the Swartz plate. Here, this is the Swartz plate, and you have this. You see, this is the shoe, small angle shoe. This is the shoe. The shoe is already fixed to the Swartz plate, and this piston is connected to the Swartz plate by the shoe, right? So the piston, the total number of piston is already located in the cylinder barrel. It's mentioned over here. The piston are placed inside the cylinder block. Now, what is the cylinder block? This is cylinder barrel and block is both the same. This is the cylinder barrel, right? So inside the cylinder barrel, you have piston. The piston is connected to the swash plate with the shoe, and then the swash plate is moving once you start the motor. So as you start the motor, this swash plate starts to move. Once it starts to move, you will get a reciprocating motion as the cylinder. Once you get a reciprocating motion at this piston, not cylinder, at this piston, the lower side of the piston will start to suck the oil, and the upper side of the piston will start pushing the oil into the system. This thing is mentioned over here, I think. As you see, the piston rotating along with the barrel in line with the position of the swash plate. The piston are placed inside the cylindrical block, or means the barrel. The movement of the piston causes a difference in the pressure, which causes the suction of the inlet fluid. This is the suction side of the inlet fluid. Okay. Now the inclination of the vertical position of the swash plate is up to 4 to 15 degree. What does it mean? It means you see the swash plate is already inclined, and the maximum inclination is up to 15 degree. One catch is that once you have the maximum inclination of the swash plate, you will get the maximum flow. And once you have the minimum inclination, that means 0 degree of the swash plate, you will get a zero flow to the system. The same thing is mentioned over here. When the angle decreases, means it coming back to 0, we have the less suction. Less suction means once you have less suction, obviously you will have the less discharge. All things are interrelated. When the angle increases, we have more. So when the angle of the swash plate is on the higher side, we have more suction. Eventually, we'll get more fluid dispersing to the system. Vice versa, when we have an angle decreases, the angle of the swash plate decreases, we have lesser fluid to suck, and hence the pump will give the lesser flow to the system. Since the swash plate angle can be varied mechanically, as I mentioned, 10 to 15 degree it can be varied, but if you see the datasheet of A10V and A4 VSO, it can be varied from 0 degree to 15 degree. Since you can easily adjust the angle of the swash plate, it is called variable axial piston pump, right? I've also furnished one table to understand the basic difference of A10 VSO and A4 VSO. Going by the size, A4 VSO caters a higher size. It starts with 40 cc pump up to 1000 cc. For A10 VSO, it's only 15 cc to 180 cc. There are two separate series are available. 31 series. It's a quite old series. Now the nowadays we are using 32 series pump. Coming to the nominal pressure, that is the maximum nominal pressure for any system which operates near about 300 to 350 bar. Easily you can use A4 VSO pump. It's quite reliable and it's there in the market for last 4 decades. Right. Then we also have A10 VSO, but the maximum pressure a bit lesser. It's maximum 280 it can withstand, but as per our expertise, I think we suggest customer to use up to 250 bar. Coming to the controller, as far as this A4 VSO pump is considered, we have varieties of controller from DR, TP, DRG, DFR. That portion we will see into the next slide. But that A10 VSO is concerned, we have restricted controller, DR, DP, DRG, and DFR. Now, what are these controller is all about? We'll see into the next slide, right? So what I have done is that I have projected total 5 controller over here. Start with the DR. What does it mean? DR means pressure control. So you can keep a constant pressure in the system by using this kind of controller. What does it mean by FR controller? FR means your constant flow control. Okay. Then the DFR is a combination of DR and FR. We called it pressure and flow control. Then we have a sophisticated version. We called it LR2 pump. It basically power control valve. So this characteristic, whatever you are seeing, it's basically flow characteristic curve. Right. For an example, if I see the DR control pump, what does it mean? In the x-axis, we have put the pressure. In the y-axis, we have put the flow. So if I follow this graph, it means that my pressure will remain constant irrespective of the flow. So DR means the same, pressure control. You are controlling the pressure, means I want to achieve a constant pressure in the system. So this graph is also envisage the same thing. It's showing that we are getting a constant pressure irrespective of the flow. So that's why we call this DR controller. I would like to show you this one schematic diagram of this controller that I have already attached so that you can easily understand. So this is your pump, right? This is your pump and this is your controller. I hope you have understood what I am trying to emphasize over here. This is the pump. This is your controller. S is the suction, B is the delivery port. You see this arrow line? This arrow line indicates the source plate that we have discussed in the last slide. And this is we call the balancing cylinder with a bias spring. So what happened? You set the pressure over here. We called it pump controller. So there we get a compensator where, suppose for an example, suppose I want to fix the pump at a 160 bar. So what I need to do, I need to set this pressure, this spring at 160 bar. So the pump will automatically start discharging the oil into the system until or unless it reaches a pressure of 160 bar. Once it reaches the pressure of 160 bar, what will happen? The source plate will automatically comes from 15 to 0 degree position so that the pump's ultimate delivery to the system it comes down to 0. What I mean to say, once this pump achieves 160 bar, the pump will deliver 0 flow. We called it 0 displacement stroke. Again, once it doesn't discharge any flow to the system, but the cylinder being actuated, obviously there will be pressure drop in the system, and same the pressure drop will be sensed over here. Again, this source plate will open up from 0 to maybe whatever the degree you have set, and it start delivering the system the oil to the system. And this process is a continuous process. So you will get automatically the pump will operate at 160 bar. So in 160 bar, when the pump reaches, it will give you a 0 flow. When the pressure is go down below the 160 bar, the source plate will open up and it disperse the flow to the system. This is the basic operational principle of any variable axial piston pump. In the same philosophy, if we see the FR control pump, it says the same. Your flow is constant. Your flow is constant, right? Irrespective of the pressure. It's just the opposite of the DR controller. It's a typical symbol of FR control pump, but nowadays we don't use this FR control pump because it is very easy to use this pump when you have 1 or 2 actuators. If the number of actuators are on the higher side, it's better to use DR or DP control pump and use those philosophy by implementing the valves. You also have the flow control valves. Now coming to the DFR controller, it's nothing else but a combination of DR and DFR. What does it mean? It's a pressure and flow control pump. As you see, another modular compensator is added over here. Earlier in the FR and the DFR, what we have seen, we have restricted the symbol up to this, up to 5. 2 is additionally included, and also one tapping is taken from the outside of the discharge line, right? So what does it mean? Whenever you are using a DFR controller pump, it senses the pressure, and what it tries a constant flow. It tries to give a constant flow across this orifice. You have an orifice at 4. So as we all know, if we change the pressure at the both side of the orifice, so obviously your flow through the orifice will change. So the purpose of the DFR pump is to give a constant flow to the actuator irrespective of the variation of the load. That is the purpose. Our other philosophy will remain same. You also have a source plate, and the operation will keep on going in the same way that the DR operates. This is an interesting operation. We called it, as of now, we have talked about your DR, FR and DFR, right? Now we'll go to the LR2 pump. We called it power control. If we go by this overall flow chart, from this hyperabolic curve, it's clear that with a constant power, because power means flow into multiplication with the pressure. So if my pressure is high, I will get a lesser flow. If my flow is high, I will get a lesser pressure. Ultimately, P into Q will remain constant. So this is the operation philosophy of LR2 controller. And this is the symbolic presentation. Now question is where we use this kind of pump or controller. Basically in the testing unit. When you set up a maybe in the metallurgy or in foundry industry, different kind of valves you are using. So to test those valves, obviously customer need a testing unit. For the testing unit, we use this kind of LR2 pump, so that once we test those valves with a higher pressure, with a lesser flow, and in the opposite, in the other direction, in the other way, we test those valves with a higher flow and the lesser pressure, at a lesser pressure. From LR2 controller, now we have we will move to EO controller. What is it? Is the electronic control. Going to the schematic presentation of the pump, you see is a proportional valve over here. There is a swash plate and there is a control spring, control cylinder, but you have a LVDT. A linear, it's not a linear, it's an angular position indicator. What it does that whatever the swash plate angle will be there, the signal will automatically go to the pump controller. Pump controller will adjust the flow so that whatever your desired angle of the swash plate, what the wish you are having. Suppose you want to put the swash plate at a 10-degree position, right? Now because any of the reason the swash plate changes to 9 degree or 13 degree. So this encoder, we give a signal to the proportional valve that no, I want this swash plate angle again to be shift to 10-degree position. So this is a much more complex and sophisticated solution. We call it EO solution. In maximum case in press and plastic industry, you will get to see this EO controller. Having covered this 5 controller, I will just request you, this is not the limited controller. We have varieties of controller. I have only tried to restrict the controllers because it's a vast subject for the A4V and the A10 VSO pump. So whatever we have talked about is about the Rexroth saga, the technologies we are having. Then we move to this domestic market, the international market, and then we have talked about the pumps, basically VSO pump, A10 VSO and A4 VSO. Now we'll be talking about the proportional valve, very interesting chapter. Before starting this, we have to understand what is a proportional valve, right? Let me open this pointer. Right, what is a proportional valve? I will show you a schematic presentation. What does it mean? This is an orifice, okay? It's a basic orifice, what you will see in any DC valve, any proportional valve, any servo valve. So our purpose is to control the orifice. Now, how do we control the orifice? We have to give a external force. It could be current, it could be voltage. By applying those external forces, we will try to control the orifice to get the desired result. It is mentioned same way as a proportional valve is a valve that is capable to change the output. It could be pressure, could be flow, right? In response to the variation of the electrical input. So as you change the electrical input, you will get a different kind of output. So that is the basic philosophy, that in a DC valve, you cannot change the output. You cannot vary the flow. You cannot vary the pressure. But in a proportional valve, that features is already there. And how does that is possible? Because you are adding another element to it. You are putting currents and voltage as an external influential figure to do this. Now question is that why the proportional valve is required? Though we have the lot of directional valve, why this proportional valve is required? Because once there are so many applications are there in the market, that if I operate those applications with the DC valve, we used to see lot of jerking, start-stop issues. To redress those issues, proportional is one solution. at the same time, by using the proportional valve very smoothly in a remote way, you can control the machine. From the PLC, you can easily control the machine in a n number of varieties of speed. And the last, very important, is the synchronization of the actuators. In the master slave control, we can do this synchronization operation by introducing a proportional valve. Having understanding the basic what is a proportional valve, why it is required, now we have to understand the basic differences and what is the principal operation of the proportional valve. To understand that, I have attached two graphs. On the right side, you see this is the proportional valve, and the left side, see it's a solenoid valve. In the Y and the X axis, I have mentioned the stroke and your force, because ultimately the force, it pushes the armature or the spool to get a position. I will come to this to the position I am talking about. But if you see this graph, what does it mean? It says that in a proportional valve, irrespective of the stroke length, you will get a constant force. You see, if the current changes, then only in that scenario only you will get a separate force. Otherwise, for a constant current value, you will get a constant force across the stroke. But in the DC valve, what happened? If you can give a constant current value, but as the stroke increases, stroke length increases, the forces also increases. And how come we will understand that? To understand that, we will see the governing formula of electromechanism, right? This is the basic formula. What does it mean? The important aspect is your G and the F relation. F is the force, the magnetic force. G is the gap, right? So what is the gap? The distance between the solenoid and the piece of metal. Okay. So the question is that in the DC valve, your G does not remain constant. So as the G changes, it comes down, your forces increases. And in the proportional valve, the G remains constant. So with a constant I, you will always get a constant force, right? To understand it more comprehensively, I have already attached another philosophy. I think if 3 slides you can collaborate, you will understand it easily. This is a DC valve and this is a proportional valve. This is a construction of the DC valve. This is a construction of the proportional valve. Now you just focus on this area, right? This is the air gap, the G, right? Again, I am moving the G. This is the gap, the distance between the solenoid and the piece of metal. So this is the G. So this is the direction where the solenoid is moving, the armature is moving in. Okay, so as you putting a current to the solenoid, obviously your armature is moving inwards. So that means you have a lesser gap. Once you have the lesser gap, this formula shows you once the G goes down, your F will come up, right? But on the contrary, the construction of the proportional valve is such that the G, the gap, right? The gap remain constant. So whatever the position of the spool, the gap throughout the position of the stroke would always remain constant. Henceforth, you will get a constant force. So that is the basic difference. Same thing is mentioned over here. Applying a current to the coil creates a magnetic field, right? Which when passed through an appropriate core material can result a magnetic force. The force when applied to the movable armature will result a motion towards the core. That is the basic principle of the solenoid, right? The force of attraction means the coil, the armature is moving inward. The force of attraction increases with the decreasing gap. As I told you, as the gap decreases, the forces increases, because you remember the formula, as the G goes down, F will increase. In case of the proportional valve, solenoid are shaped in such a way, the armature, coil and the pole piece, such that the force of attraction is relatively constant over the stroke, right? After studying all this, now if I move back to this slide, so this is the basic difference of a DC valve and proportional valve. You go along the stroke, your force will remain constant if you are providing a constant current to the solenoid. But in a solenoid, if you go through the stroke, you will get a higher force as the armature is crossing a stroke, right? So this is the basic difference from DC and the proportional valve. Now moving forward, how does a proportional valve works? So basically, you have to put a electrical signal. It could be current, could be voltage. You have to put a electrical signal to the amplifier. This amplifier represents over here. It's a card, nothing else. This card operates the proportional valve. Okay, this card. So first of all, you are putting a signal to the card, means to the amplifier. Then amplifier signals it to the proportional solenoid, and based on that signal, the proportional, it could be DC valve, could be pressure valve, could be flow control valve, reacts. And when this valve reacts, automatically your actuator, which is connected to the machine, gets actuated. This is a basic presentation. This is the flow control valve, flow control proportional valve. This is a pressure reducing proportional valve. This is a DC proportional valve. This is the amplifier. This is your cylinder. This is the actuator connected to the machine, and this is your motor. So on the top side we have a reciprocating motion, and in the downward we have a circulating motion. So this is the basic philosophy. How does a proportional valve work? Now move to this overview of the Rexroth proportional valve. What Rexroth is having in the bucket. This is the overall philosophy. I think we have a proportional valve. There are three dimensions to it. One is directional valve, pressure reducing pressure valve. Then we have a flow valve, right? For the directional valve, we have two categories: direct operated and pilot operated. If you see a deep dive to it, you will get to see with the spool feedback position we are offering for both the condition. Suppose you have a direct operated valve. If you want to have a spool position feedback, that we can provide. If you do not have a spool position feedback, that we can also provide. So both the features are available in direct operated proportional valve as well as pilot operated proportional valve. I've also attached one or two example to it, like 4WR EE. This is a proportional valve which is directly operated but having this spool position feedback. What does it mean by spool position feedback? Suppose you are giving a signal, a command value to the proportional valve. Obviously, spool will start to move, right? So whatever the movement has happened to the spool, that signal will come to the PLC in an analog format. So we mean to say spool position feedback means that is okay. It could be 4 to 20 milliamp in maximum proportional valve. Now coming to the another model, 4WR AE, that is the same. It's a direct operated proportional valve, but doesn't have these features, the spool position feedback. So once you have a spool position feedback, it guarantees you to have a closed loop operation. Once you do not have this spool position feedback, generally we normally use this 4WR AE valve in an open loop operation. Same philosophy applies to the pilot operated valve. In the pilot operated valve, see, one thing is absolutely clear: the direct and pilot operated are basically segregated in terms of their LPM capacity. They are having a much lesser LPM capacity, and pilot operated valve has a higher LPM capacity. Maximum case you will get to see from NG6 to 10 that belongs to this direct operated valve. From 16 to 32 you will have this pilot operated valve. So coming back to the model code, I have attached one or two examples, 4WR KE, and example for the pilot operated proportional valve, which is having a spool position feedback. And another way, 4WR ZE, it's also a pilot operated proportional valve, but doesn't have a spool position feedback. Same philosophy is applicable for the pressure proportional valve also. We have relief valve, reducing valve in the category of direct operated and pilot operated. Same features are also attached with and without feedback. Let's see some of the models. These are the models that I have mentioned over here. Apart from that, we have interesting features we called a high response valve, because these valves are basically needed for the application where precision is on high demand. Here we also have this direct operated and pilot operated valve. These are the examples of these valves. Once we talked about these high response valves or the servo valves, though I have not covering the servo valves over here. Once we talked about this high accuracy valve, the major important point is your step response time. How fast the spool moves from 0 to 100 position. So the maximum spool can move with the high response valve is with approx 10 millisecond. And the other features is like the maximum pressure capacity handling, the nominal flow, and the size. So this is the overall concept and the overview of Rexroth proportional valve. Having said that, I would also like to say that I have not covered the servo valves. It's a separate chapter. I think it's a very interesting. Later on stage, if we get to have this opportunity, again we will showcase the details of the servo valves. But overall philosophy, mechanical construction point of view, there is a difference between servo and proportional valve, but this response time plays a very important role in both the valves, high response proportional valve as well as the servo valves, because they deals with this high accuracy closed loop operations. This is a typical schematic presentation that we have put over here to understand how does the cylinder operate when with a particular position of the proportional valve, right? Same analogy you can relate to the DC valve also. So this is the neutral condition. I hope you are able to see over here. We have 3 position and 4 port, right? So that's why we called it 4/3 position proportional valve, right? 4/3 position, 1, 2, 3, and if you see any position, there are 4 ports, P, A, B, and D. So that's why 4/3 position valve. So in the initial stage, it is in the neutral condition. The no flow is passing to the cylinder or coming out of the cylinder. Now, if I changes the position from this neutral to this position, means the parallel position, when the oil can easily pass from P to A and come from the cylinder A to T. So how does it look like? Oil passes through P, then is go to the A port and directly going to the cylinder. By doing this, cylinder is getting extended. While the cylinder is getting extended, you are obviously having a backward flow from the annulus side through the proportional valve to the tank. So the P to T connection is open, right? So we have 2 open channel, P to A pushing the flow to the cylinder, B to T is all in another way is just connecting the line from the cylinder to the tank so that cylinder can easily be extended. Same analogy we can apply over is a cross functional team. So P to A earlier stage we have connected, now it's connected to P to B. Once the P to B is connected, you will get the retract motion. Here we are having a extend motion. Here we have the retract motion. So P to B is connected. Now A to T is connected. So this is the basic concept of any cylinder which is being operated by a DC valve or the proportional valve. Here we have symbolically presented as a proportional valve. We will also see the type of spool that is used in the proportional valve. As you see, all ports are closed over here. We called it overlapping spool. In the next slide, we will see the details of what does it mean by overlapping spool. In the middle of the section, we see that P, A, B, T, all the ports are connected. We called it underlapping spool. And in the last picture, what we see in the P, in the neutral position, the P is blocked, right? We called it 0 position. So first we get the overlapping spool. In the second, we get the underlapping spool, and the third, we get the 0 overlapping spool. Now, what does it mean to this all the spool, and how does the spool characteristic of the proportional valve varies if we changes the spool configuration? That we will see in the next slide. We'll start with the positive overlap, but while studying this, we have to idealize this flow characteristic curve. If I go by this positive overlap, I have to follow the graph A. Okay, this is a flow characteristic graph. Have to follow A. Okay, this is the graph of A. What is mentioned over here? It says that control opening remain closed until input command what you are giving, it reaches 15%. It could be plus minus for opening this spool. Okay. If you see this particular presentation, you see the P line, P2A or P2B, there is a gap. So that gap means it close. To open this gap, you have to put at least 15% of the command value. And that's why you see this is your command value, this is your flow. Until and unless you are giving a 15% command, you hardly getting any flow for this A curve, right? So that's why we called it positive overlapping. Same philosophy applied to the negative overlapping. There is a constant flow via both the control lands. Land means P2A and B2T at the zero level input command value. So when you are not giving any signal, but still the flow will pass to P2A and B2T. We have to follow the curve B. What does it means? It means this is a juncture where you have to have a you are having a zero current while you are having a some flow. You see, if I follow this B curve, what does it mean? It means that once, though I am having a zero current to the valve, but still I am having a flow. That the same thing is reflecting over in the stating in the negative overlap. But these overlap are very important while you are using this valve in a closed loop operation. What I mean to say, these valves are very important whenever you are using a most precise control. Basically servo valves and high response proportional valve that I have shown few slides earlier. Most of the cases, if you want to achieve a high precise movement, then you have to use this kind of overlapping, negative overlapping. And ultimately we have this zero overlapping. It's nothing else, is the in between B and C, A and B we have a C. It's absolutely straight, right? At the zero command value you will get a zero flow. Zero command value you get a zero flow, but we get a small overlap over here, 0.1%, but it's not same as the positive overlap. In the positive overlap you have 15% overlap, it's a less than 0.1, right? This is required. So this is the basic concept of this positive overlap, negative overlap, and zero overlap. Now coming back to the Rexroth proportional valve, if you see the data sheet, we have separate nomenclature and demarcation to the spool. It goes with E, W, Q, this V type of spool. I'm not going details of the things because it's already mentioned in the data sheet, but my intention is to touch upon the overlapping, what we are getting in the spools. From the spool, we will directly shift to the curves. If you go by the any data sheet of the proportional valve, you will get to see this curve. In the x-axis, we have the command value. In the y-axis, we have this LPM flow. So what is the purpose? This is the governing principle, right? So if I remove the I from the equation, that is the basic fundamental fluid dynamic equation that we used to study in the colleges. Right, Q is directly proportional to the root over delta P. I think your Darcy-Weisbach equation also states the same. But since there is another external factor to that, so that's why we have put I into it. It could be V, but fundamentally Q is proportional to the external factor multiply into root over delta P. So to talk about in details, ultimately we have three variables over here. Right. So if I have to put a graph, one variable have to keep on a constant parameter. So here what the graph says, they are putting delta P on a constant level and then they are putting a graph. Okay. So if the delta P remain constant, the Q is directly proportional to I. Right. So it says that, for an example, I take an example, 150 liter nominal flow, right? What does it mean? 150 liter nominal flow with a 10 bar differential pressure. 10 bar differential pressure means pressure across the valve. Sorry, that's a P2A. While the flow passing through P2A, there will be delta P. Suppose you demarcate it with a delta P1. There will be another delta P while the oil is passing from B to T. Right, you demarcate with delta P2. So ultimate differential pressure would be delta P1 plus delta P2. So 10 bar means the overall delta P. Excuse me. So this 10 bar also indicates that you have 5 bar delta P across P2A and 5 bar delta P across B2T. Overall 10 bar. Sorry for the inconvenience. Okay. Now we'll see the very interesting topic of the proportional valve. We called it hysteresis. What is this? It's basically the accuracy. Accuracy means whenever you operate a proportional valve or servo valve, there is a what we call a cyclic operation. Right, we are giving a signal to the proportional valve. Suppose the range of the giving a signal is 4 to 20 milliamp. So the middle of this is 12 milliamp. So 12 milliamp to 20 milliamp, it's in ascending order. Then 20 milliamp to 12 milliamp, it's a descending order. Now the interesting fact is that suppose we have reaching a figure of 16 milliamp, right? From 12 milliamp, we are reaching a figure of 16 milliamp. Obviously 16 milliamp will give you 1 LPM. But if you reverse this, you are descending the order. You are coming from 20 to 12. You also get a 16 milliamp value, but the value of the 16 milliamp while you are ascending and while you are descending won't be the same. So that phenomenon we call the hysteresis. It says the performance of the proportional valve will show. It has to be will show a slight difference when the current signal is increasing than when the current signal being decreased. So when you are giving a current signal which is in the incremental pattern, and again you are giving a signal which is in the decremental pattern, but both the cases for a particular current you will not get the same flow. The hysteresis is defined as the difference in value of input current required to produce the valve output during the single cycle of the valve input current or vice versa. Here in the image, it shows that if I take this value of 60%, right, flow, and if I draw a horizontal line, it will intersect in both the curves. So it means that if I want to have a same flow while I am giving a signal from 12 to 20 milliamp, and another way when giving a signal from 20 to 12 milliamp, it won't be the same. So the difference we called it hysteresis. Right? It could be measured in milliamp or command value, or it could be measured in the flow or output point of view. I think hysteresis is a quite interesting point, because most of the cases while you are using these sophisticated and high response servo proportional valves, the hysteresis you will see in the dataset is much lesser side. But in a conventional proportional valve, it won't be the same, right? So once you have a faster response valve, your hysteresis will be lesser. Once you have this normal orthodox kind of proportional valve, your hysteresis won't be that short. You will get a moderate hysteresis inherited into the valve. After having discussion on this proportional valves, this is about this new and focused product. We called it connected hydraulics. Basically, nowadays it's a new product to the Rexroth KT. We called it AV Max. It's a modular concept of large hydraulic power unit. There are several modules available. As you see, this is a pump motor station, this is a tank, this is a circulation unit, this is a return filter unit. We called it MPU, MPB, MTU. Then in the similar way, MPU, MPFU, MCU. And talking about the features, this is the maximum capacity the AV Max can handle. You can easily use this modular concept with 2000 liter to 1800 liters tank. 1000 liter tanks, and for the pressure rating is up to 315 bar. Both the pumps can be used over here, A4V and A10V. The flow is can be set up to, it's a total flow, huh? It's not a single pump flow. It's a total flow up to 6 to 5 lpm. The purpose to introduce this model is to push, because nowadays you see different kind of customer gives you different kind of circuit. So from the valve table point of view, it's not possible to change the algorithm or the logic, but in the power unit you can make it standardized and modular. So Rexroth intention is that we want to develop a product that we have already developed, like AB Max, that by implementing this modular concept, we will see the customer requirement, and based on the customer requirement, we push this modular concept like MPU, MPP. Suppose if I ask a customer, what is your tank size? He says that 2000 liter. Okay, then I'll check my Excel sheet, and from the Excel sheet, I get, okay, that MTU tank unit means MTU. MTU, I have 5 variation. For the 2000, I will pick the one. So this reduces your engineering time, because for drafting this circuit as well as preparing the GA, it takes a lot of time, maybe 1 to 2 months. By doing this AB Max, I think it hardly be done within 1 week or 10 days. So this is the one concept, we called it AB Max. It's quite renowned in the European region. In India, or maybe after the pandemic, we are pushing this product into the market. We also have this Citronics. We call it smart and energy efficient solution. This is a very interesting product. Nowadays in the retrofitment activity, we are using it. The basic benefit is to that it's a lower energy cost, right? Because maximum industry you see that actuators are not being operated, but still the motors and pumps are running. So ultimately your energy is being wasted. But if you use this Citronics, you can easily save those energies. There is variation in terms of Citronics modules are concerned, FCP, DRN, and CBP. We have a servo motor in the CBP. FCN is basically your is a combination of gear pump, small gear pump with a asynchronous motor, and DRN is a variable axial piston pump with a asynchronous motor. So overall, this is our main focus product, AB Max and Citronics. The nowadays we are pushing into the market. The Citronics also gives you a lower carbon dioxide emission as well as lower noise emissions. So ultimately, our motto is to move to you win, and that's the motto we have been following last so many years. And our endeavor is always to give the sustainable solution, as I mentioned in the earlier slide, to the customer so that they can get benefited out of it. And this is the overall presentation that I have to show you. Now the platform is yours. Any question on this topic apart from this, you can ask. I will try to keep the answer to it. Thank you.
Thank you very much, Mr. Sinha.
Yes, thank you.
Yeah. So, gentlemen, do we have any questions? So if there are no further questions, we'll move on to the vote of thanks. So, gentlemen, we have indeed had a very interesting webinar today on the topic Foundry Market and presence of Bosch Rexroth. We are sure the content of the presentation had a lot of takeaways for our audience. We'd like to thank Mr. Debraj Sinha, Manager, Engineering and Application, Bosch Rexroth, taking time off his busy schedule and making us rich with knowledge. Further, we would like to thank all the members who joined us. Yes, sir. Yes, sir. And I'm sure you had a wonderful learning experience. And
Absolutely.
Thank you
Absolutely.
for joining us today and making it a wonderful audience. We from Chennai chapter will be conducting many such interesting programs, and we'll be sharing the information to you soon. Looking forward to your participation in our upcoming programs. Thank you very much. Thanks to all the people who joined. And thank you, Mr. Debraj.
Thank you. Thank you all.
Thank you, sir. Thank you. Thank you.
Thank you.
Thank you, sir.
Thank you very much.
Thank you.
Thank you.